Tack. Hello! I'm Jacob. I'm mostly a developer, sometimes a designer, and I'm fagleder in Variant Norway, which is to say the best translation I've heard so far is guild leader. So that's a thing. Recently, I've been fortunate enough to work with a lot of colors. Where I'm at, we're doing a white label solution for kind of banking, mostly credit cards and other credit products, but also high interest savings accounts. So we launched a new platform this year, and that's going to replace some old ones. And yeah, the kind of one of the driving complexity factors has been theming. So the one that we've got now is just swap out the color. Everything's blue, everything's red. But we got to do a new take on this, and I was fortunate enough to work with a really great designer who did a lot of work on design tokens. Lene, for those of you who know her. And we began to experiment some with OKLCH. I'm just going to try to say OK, because saying OKLCH is going to take a lot of time. So one of the a lofty goal was to have one color to be one palette or a set of swatches to make theming easier. So yeah, this is my talk, how to perhaps change how we use colors in web development or just design in general. But before we can dig into that, let's talk about Hex, because Hex kind of sucks. Not that Hex sucks, but it sucks. Because it's just a kind of a result of color pickers, right? So we pick a color, and a color pick is a really great abstraction, because we rely a lot on our eyes to see stuff. And Hex is just computer speak for RGB, because it's a set of six characters or numbers, which, when taken apart, translates into RGB. And you could theoretically understand the syntax. Many of us probably should by this point, just by being exposed to it. But no one. I mean, I know of a white color when I see one. And like 0, 0, 0, 0, 0, 0, right? And then I can do like badass and stuff with. But yeah, it's a terrible color format for making color systems. So a few years ago, HSL came along, and I thought, yes, this is it. This is how we can do colors and systems. It was invented in 1970, so that kind of says something about it. We probably didn't know a lot about colors then on monitors and design systems, right? But it was widely available in browsers in 2020. And yeah, just let's explain the syntax. So we got HSL, stands for hue, saturation, lightness. So hue, that's just the color we write. We go like, wee. Yellow, it would be found at 50 to 60, green at 120, cyan at 176, or the like, blue at 2. So yeah, you can read numbers, I don't have to. And then you got the L, which is lightness, and that just increases, right? So when we increase the number, we increase how much light there is behind it. And this goes up, 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 until we reach 100%. That's so. And also, I should mention, saturation here is set to 0, and the hue is 0. So hue, if you were paying attention, hue is red if it's 0. Then saturation. Now I locked hue to 120 and lightness to 50%, and you can see that with when we increase the numbers, the color go up. Color goes brrr. Wee. Just kidding. And the 100 is obviously the most vibrant color then. And let's have a look here. So we got red, right? 0. We can decrease the hue, so which goes to 360, right? And isn't, yeah, this looks decent, right? But HSL hides a dirty secret. All right, that's that it's not really great with contrast. So if you work in design systems or with colors, you know yellow, right? Yellow is horrible to get contrast right. You're trying like, yeah, that looks right. Nope, doesn't. So if you kind of get rid of the so I just turn gray filter on, right? And you can see that this 10 here is a lot darker than 10 here. And you can also see at 40 at orange and red. It's not very, that's a distance in contrast. And you can also see it in blue and purple. Moving on. So if you were to, Elise's, talk about accessibility, you know this number, right? How much contrast there is from this text to this background. So when we got just no saturation at all, and we get, this changes nothing, right? Because there's no saturation, which means no color, just gray. We add some saturation, right? And if we we change the background. And you can see that kind of varies widely on how much contrast we're getting, right? So it's from 8 down to, oh, that's a lot of contrast, right? This is still good, right? But kind of, because this is black, obviously. But if we were to decrease it and still have, you'd see that, yep, there's still a lot of changes in the number. So it's not consistent. So the problem then, HSL is bound to sRGB, which is a color space that were invented a long time ago, probably when CRT monitors came along. And it has all the usual suspects of color functions that we've heard of, like HSL, RGB, and there's a lot of HSV, but they're kind of based on the same color model. And the color pickers too uses sRGB. So if I were to change here, you can see that in blue, it kind of becomes darker. So it's not, we can't really use a color picker either to be like, yep, here we go, and then I turn it to the, yep, nope, that's not the same. Even if we change them to down here, it's just in the same kind of space. And then we got the other stuff, which that is sRGB only covers 30% of the human visible, the colors we can perceive. And then we have gotten a lot better technology when it comes to displays. So the point of why I'm making this talk is OKLCH. Oh, okay. Let's not do that tongue twister again. Okay, so it's based on research. So this is very modern in like web technology. This is as modern as it gets. Like the science and the fact that it was created, I don't know, maybe 4 years ago by a Swedish dude named Björn Ottosson. And why it's cool, why it works, is that it's unbound from any color space. So it's based on how we perceive colors rather than how a computer wants to show colors. More on that later. And that we get more color because it's not bound to any specific color space. It means that if our screens become better, we're still using the same format. And of course, it's perceptually uniform. So we'll also see that later. And yeah, it should be worth noting that it's both forgiving and unforgiving at the same time. So HSL and the other, when you get them a color or a value, you're always going to get the color, even if that means like distorting colors. That doesn't make sense, but yeah. The syntax is kind of the same as HSL. We got lightness, and then we got hue. And then in the middle here is the kind of where the complexity lies, which is chroma, which is kind of the same as saturation, but not quite. Yeah, so here's the hue wheel. And we got an OK wheel. And if we were to like turn on grayscale here, we can see that it also shows something that is important. So, and as a bonus, we get better gradients, right? That's blue. That's blue. That's white. That's white. Why is it purple? I'm just asking. So it kind of resolves gradients a lot better for some colors, not every color. You can see that when we're turning it about, you can see where it's in some cases it's very good. In blue, it sucks. Somewhere here, it's kind of awkward too. Oh, wait. All right. One moment. There should be another thing here. Anyway, yep, let's instead, I'm going to do that one later. I'm going to do this one before. So to better illustrate how OKLCH works, has anyone been on this webpage? Some? Yeah. And how terrifying was that? Yeah, so HSL is kind of, if you were to look at a map, and it is a flat map, like you want to hang a map on a wall, and it looks good, like it fits. But sometimes you want a globe, right? Because that's when your coordinates are very important. You kind of want the complexity of a round thing. And that's kind of, flat maps works for when you just need to look at something small, and then a globe would be better if you want to do the whole thing. So this is a visual representation of OKLCH, where you have on one axis, it's just lightness. It goes from light to dark. And another one is from hue, so from red over here to red, or 0 to 360. And then in the middle, you can see that there's like valleys and mountains. And these are chroma, right? So it's how much color there is in on a given hue with a given lightness. We can see that there's color on different places, so to speak. And this is the complexity that our eyes actually have, or in compared to or in context to screens, right? So we couldn't. That's why colors, yellows are hard, right? Because there's not a lot of yellow, but there's a lot of green and a lot of blue. So, and it's better illustrated here. So, and because OKLs is unbounded from color spaces, we can see that there are more colors to be had once the screen technology gets better. So P3, that's kind of all the high-end mobile phones, the last, I don't know, many years. And Rec 2020 is like very good high-end TV sets. And then you get a lot of color. Yeah, so this kind of works if you look at this. If you lock this one, you can see that this is how much chroma we can get from this. Given this lightness, I can change chroma this much. So you can see the center here with a kind of crosshairs that you can get pretty high up. And also this is what I mean by still forgiving and unforgiving at the same time. You will always get a color, right? So if you were to crank this up to max, you'd get the most vibrant color there is at this given hue. And sometimes you get very funky results. But anyway, that's kind of how that works. And so my kind of end game here is to show what is possible in this. So imagine you got a color palette, right? And being the good designers or developers that we are, we've instead of just using 200 straight up, we say, yeah, 200 is probably strong text, foreground text. And the background here is probably 800, but instead of saying that, we give it a name. But and we can see that the accessibility checks out. Cool. But what we could also do then, because we know that it's perceptually uniform, and we're like, yep, we've made sure of it, in which I'm going to explain later. But then we could also like change the color. We want a muted blue. Yep, that's still good. We're still good. Nope. Yep. Okay, so that one. No, don't do that one. But this one and that one. And then we could like, yeah, we could do green, I suppose, or we could do red, and we could do purple, blue, and we'd still get like at least a guaranteed minimum of contrast. And if you would do this with HSL, you kind of saw that blue would totally crash the party and be like, no, I'm not doing that. So, and because we've bound them to kind of to be a thing instead, we could also invert them, right? Because that would just mean taking from the other side of the scale. Also, this is kind of just to show what's possible, right? So we could take any color, pick it here, do it there, biddy-boo, biddy-bee. That looks nice. And we could invert the whole thing, right? So it's just from here to down there. It's the same palette or scale, if you will. We don't have to deal with stuff like color 300 red or color red 300, color blue 400, color whatever, and a number. Instead, we just do color all the way. And why this is nice is this is where the magic happens. So the other example was HSL. This is OK, which is also, I should explain that why it's OK is because the former, just HLCH, it wasn't that good, but OKLCH is OK. Anyway, so we can see now that when we're turning up the chroma and hue, you can see that that number there stays kind of the same in much larger degree than what were possible in HSL. And this could really work to our advantage. If we were to, so I've locked the chroma or the hue to be the same as up here. We could see that, yeah, we could have some text with just as a monochromatic kind of thing, where we want some. So imagine, just as is usually the case in design system, then is that you do black on colors because it's easier. It's a bit harder to code the things that it's, yeah, we should change the color, but then you also increase how much complexity you need of your design system in general, like because black on a surface kind of looks, it's so much contrast that it kind of sticks into your eyes. So instead, we could lean on the OKLCH and be like, yeah, you could take the wheel here and be like, that's much nicer to look at. And because this is about contrasts, we're kind of not just talking about contrast as text on a background. It's kind of contrast in everything, like borders, icons, illustrations, text, backgrounds, colors, and you get the point. So this is kind of a usual thing to see in design systems, right? Where you have a thing which has a lot of color to carry meaning, like you got success, danger, info, warning, and the whole point of them is to indicate with color what you're supposed to like carry meaning in a way. But if we were to turn on grayscale here as well, you'd see that this looks kind of familiar, right? I'd certainly say so. Oh, so this is kind of a good practice too if you ever want to do semantic colors or semantic tokens or whatever you want to call it. That the name of the border doesn't have to be linked to a certain color. It could just be that this color is called, I don't know, border strong or border weak, border something something. And then you'd essentially often you'd also give it a color name because you built the color system on top of everything predefined. So, yep, let's build a palette. So the things you saw earlier in the demo, I kind of have to explain how you do it as well. So we will need a curve and scale some steps. This is if you've ever been in a design system with colors, there will be names on the steps to indicate how much color or how much contrast there could be between them. And any hue will do, and we need some way to do chroma. But let's get back to that one. So Lea Veru has done some research on how design systems do colors and plotted them on some charts. So here is IBM Carbon, and we could see that lightness is kind of we can see there's a pattern here regardless of the color, right? We can see that lightness kind of, so we can assume that, yep, that's a line. But in chroma's case, we could see that there's a lot more going on, and hues are just like a straight line. And this kind of repeats itself on other, so let's look at Tailwind's color system. That kind of also follows a certain pattern, right? In that it starts up here and then trails off towards black. And I should say that these systems are probably done before OKLCH was even a thing. So it's kind of impressive that someone managed to make it this uniform across several colors anyway. And you can see that there's a pattern here as well. And as same as with the hue, it's a straight line. So with that in mind, we could probably say that, yep, we can stick with the same scale or curve at lightness, and we can just give it a hue, and that should be good. Also, this is the example for you can also see here. Now I'm just gonna not turn on grayscale there. And get the primer, kind of the same. Lightness, whoop, the same. Chroma follows a certain, but as you might have noticed, the chroma is where it separates between all the color systems. This is where the magic happens, so to speak. And hue, still the same. I don't know what's happening here, but that's, oh yeah, it's black and white. Sorry. Anyway, back to here. So we would need a lightness scale, and this is what gives us the contrast. So this is kind of the easy part. The easiest part of this is just defining a color or lightness scale. That could be the same throughout the lifetime of a system. You could tweak it as long as you kind of settle on a naming convention. You'd be fine. I wouldn't be angry if you did it any other way, but it's kind of, please keep in mind that this versus this should kind of be like how much contrast between something. Even if you as someone who makes a color system would at least keep in mind. And if you decide to do semantic coloring or semantic classes, that's where you'd put it into words instead, like subtle versus weak versus strong versus something else. And this would be the same as you saw, like this curve right here. That's the same as this one. Pretty straightforward that. Now chroma, on the other hand, this is where the hardship lies. As you saw, because of all the valleys and in the mountains, it's kind of hard to do it properly. I don't know if someone has been on this site to try to make a color scale at some point. Someone? Yeah, I see you. It's kind of terrifying that you're trying to do it and you're like, and I feel like, is this better than color picking in a color picker? It's kind of hard, but it's honest work. So yeah, let's try to make a scale then. So we're using the same kind of the same scale as here, just put into boxes. So this would be a representation of if there's no chroma, this is what it would look like. Because we haven't added any colors yet. And you can see from my little practical guide here that it's not a lot to a little gives a lot. And while it's theoretically possible to go beyond 0.4, we don't have the technology. Anyway, so let's do some add some chroma. Nice, all right. And it's kind of easy to so I've added some extra information here to relay when things are not as they seem. So here we can see that if by the swatch here with the most amount of light, we also have the least amount of color to go up. So it's because we got so much light, it's so close to white, and then you're trying to add color to this. It's like, nope. In this color space, I can't do. So this is where we would get a fallback colors, kind of like we had over here. So this is where unavailable on any device actually. Yep. So we can't do that. So we have to turn it down, and it's like, nope, can't do that. And at some point, you kind of get that there is a lot of color here. Oh, not in sRGB, but we still got P3. So that's because it's on a screen that can produce a lot more color. But this is pretty damn hard to just do per color, and it's kind of sucks, to be honest, if you're gonna do this, because you kind of have to do it the same as hex. You would sit and pick colors on each and every color. That I'm sorry about just saying colors, and I know that it's hard, but is it a swatch? Is it a palette? I can figure out what the naming convention would be for one set of colors and every swatch or color inside. Anyway, yeah, as I said, it's no fun. And let's instead have a look at how we could do it with some nice CSS instead. So recently, in CSS, we got something called relative colors, which you can take one color in a color space. So in this case, LCH. So we give it a hex color. Yeah? And then we get the values from that color. So here we go. Here we've got red, right? So if we were to give red to this color, this variable, we get its lightness, its chroma, and its hue. So this color right here has exactly the same color. And as I typed that out, it's just the same color, right? We haven't done anything by it by now. But if we were to take the same color as we did, And then on lightness, we want to give it another color. That would be here. So lightness 20, we could decrease, increase, right? And we could do the same for chroma instead. So lightness would be the same as the color we picked. And then chroma, we would want to overwrite with a variable here. So it's 0, which means gray. And if we start adding some chroma, you can see that, yeah, at some point we would be at the same place as this one. And if we were to change the color, you can see that it changes as well. So that's kind of a very, very nice feature to have to make a color system. Wouldn't be possible without it, unless you want to hand tweak. And it's kind of, if you imagine a type scale or something that you can multiply or something, you could use it with calculations. You could do anything really. So like if, for example, a hover state on a button, instead of having to say, you should be this specific color when I hover it, you could say like, just subtract 10% light. So you then get a hover state, right? Instead of having to define all the colors, you can do like, I already know the color, just a little bit darker, please. So you could use math inside of it. Does this make sense? Yes, yes, yes. Sorry. Anyway, so then we could like take this to try to copy or put this color into a palette instead. And then we could clone it. And then we could do another color. And another color, right? And that's kind of the thing here is that we're, so with the same lightness, but we've also locked, so chroma is the same for whichever color I choose, right? We do nothing with chroma here. We just do lightness. So we change lightness. Lightness 10 for this specific color. We are interested in its hue and its chroma. And then we set a specific lightness for each and every one of them. So imagine this being like color 100, 200, 300, 400, 500, and so on. So we're just interested in chroma and in hue, because those two then lets us do this, and we're just adjusting lightness. That means we could pick any color and make a palette from just one color. And if we want to make it less saturated, we would give it a less saturated color. And if we wanted to be more saturated, we would give it a more saturated color. Problem though is that, as I showed you in the other demo, which when you're going towards a very much light, you'd essentially get white, right? So there's not a lot of color in white, but this then doesn't account for that. We're just using the same chroma. So if we're taking like a really acid kind of purple, we get some odd result up in here, because this should be white now, because it's 100%, right? My cool thing is that it's when it works, it works. Like when you haven't picked any crazy colors, it kind of works, but not really. And that is because of chroma and because of how it works kind of in this situation, where you'd pick a color with a lot of green, so you'd still want it to taper off at the sides, right? Because white and blacks, you can't have a lot of color in white or black. You need it to taper off. So that is why we need some math. And I'm not good at math, but I'm good at CSS. I'm not going to try to explain it, but we can do a lot of math in CSS these days. So instead of having to define a chroma scale for each and every like set of palette steps. So if for green, if you want, you do a scale for green and a scale for red and a scale for pink or yellow. Instead, we could be like, yeah, we can make a kind of a scale for each and every one of them, and then have some math like this sine function, which takes in a, so this would be the number then, and multiplies by pi. I could just hear myself. Like, you could just multiply it by pi and sinus curve, but important thing is that it works. And then use the C value from the color we picked, right? So a higher, like a more vibrant color then would result in a, oh, did it, the whole presentation? All right, cool. A color with more color. You can see why this is hard, right? Color with a color. Anyway, a color that is much more saturated, you'd get a higher number here, right? But because we're doing the sine wave and the pi thing, it could taper off instead. So that means that we're kind of tapering off at the edges, and depending on our curve, on how, or rather how we do this one, all colors could taper off at the ends, or the extremes, rather. Yep. And that's kind of what this is about. It's not so much about how to set up and hand-tune the colors, but it's more like you could use one color to give you a set of steps, color steps. And so, yeah, we could have a grayscale that just, yeah, we would like a tiny amount of green into our grayscale, because maybe that would be nice. But with the same formula, we could like be, yeah, I want my success color scale, and that would be, let's make it, is it going to be a muted kind of forest green, or it's going to be an acid green? I don't know. But that kind of, if you made a formula, that's what you would decide as either a designer, preferably a designer. So you could make the formula instead of making like hand-tuned decisions in a color picker or the scaling part, just by choosing something in here. So this could be, if you want to call it green, in our or a red, and just be like, oh, let's see, where's it gonna be over here? Yep. Hopefully this should be a lot more uniform. Yes, squirrel. Yeah, yellow. Okay, you all know this is gonna look, or some of you might look, then yeah, that's gonna be a bit, yeah, but it should shake out too, even though it's a little bit darker. Probably couldn't tell on that screen though, so that's okay. Yeah, so back to this then. So success doesn't really have to be like a success color. It could be any color, but we're just giving it, define a color and a formula which allows us to not think so much about each and every color. I said colors many times. We're using the color picker to decide one color, and then we get the entire palette for that specific one. And the same, like, yep, we could call it red, we could call it danger, doesn't matter. We just give it one color, and then we're good. And info, it's like, we're using this, by the way, for our on the project I'm working on. Is like, yeah, maybe we do want to have a different blue for dark mode, right? That would be entirely cool, because it's just one color to give us all the colors. And dark mode is kind of, you don't need as much color. There again. you don't need as much saturation on a dark mode than you do in a light mode. Because in light, you're fighting towards, or you're fighting against white, which is so much light. And in dark, you get almost no light, right? Because it's dark. And just with a little help of my friend semantic class names, you'd also get dark mode for free and inverted for free. So this is the same scale, but it's just other color names, or rather class names for this. And again, it does look. I mean, these are not the greatest examples of designer chops, but it looks a lot better than having a white. If this would be a white color on a muted green, it would sting. That contrast would be too great. So we could still be like, yep, that checks out. Use contrast twice. It checks out. That one checks out. That one checks out. Yep, and this one too, because we've defined the formula and established some rules, and that just makes it a whole lot easier to understand. Yeah. So some of these stuffs are not what would you call the browser supported, but but at least the OKLCH part. For sure, that's no problem. I think it's about 95% plus, which should be cool. But the relative colors part is maybe not so cool. So if you'd want to, you could you could still do it, but you'd need to use some JavaScript to give you the you'd still put one color in and you get the scale out. Not as you couldn't do fancy stuff like picking a color right here, but it would still essentially be the same because the math, the formula, it's still the same. And yeah, oh yeah, I had a slide. Okay, so I left this one, and I'm not going to try to say that. But it's pretty much it. You take a color. You have some curves. So pro tip, use the colors. So this is the same package as the one I'm using to do a fallback in JavaScript, but has a lot of interesting finds on colors, and use some math so that you do not have to do the old dance with trying to define stuff. And then you'd get a color, and like in Figma, if you're doing modes, this would slot in perfectly for modes. Like you do a frame, pick a mode, cool, it's the same. This is basically the same. So kind of if a developer tells you that's not going to be possible, I saw a talk. I know it's possible. And then you can refer them to me and I'll talk them out of it. Or into it, depending on, yeah. Anyway, so that's kind of what I've got. If you got any questions, I know this was like a phew, and probably, I don't know, too high of an abstraction or something. But that's all I had. Thank you for your time.